Welcome to this video on Communication Technologies, course code EC832OE.
The course outcomes include applying coding techniques, analyzing wireless communication, and understanding satellite communication concepts. We will also summarize mobile generation systems, describe optical communication principles, and explain network security encryption. For further reading and in-depth knowledge, refer to these recommended books on information theory, communication systems, and digital communications. This video will introduce you to various communication techniques. Communication means the transmission of information from one place to another. This is done through sending, receiving, and processing information by electronic means across a medium. Communication has evolved significantly, from smoke signals and fire beacons to methods utilizing lighthouses, bells, pigeons, and humans. Early forms also included semaphores, mirrors, and sounds. The timeline continues with the advent of Morse code, telegraph, radio, and telephone. More recent technologies include television, FAX, and pagers. We then move to mobile phones, the internet, and emails. The progression continues with smartphones, tablets, and laptops, making communication ubiquitous. Looking ahead, technology such as the Sixth Sense technology promises new ways to interact and communicate. You can explore more via the link provided. Now let's look at the electromagnetic frequency spectrum. This chart illustrates the various frequency bands, from VLF to visible light and infrared. This table details the frequency spectrum bands, including their frequency range, free space wavelength range, and typical applications, such as power line communication, broadcasting, and satellite services. These graphs illustrate two signals with the same amplitude and phase, but different frequencies. The first is 12 Hz, and the second is 6 Hz, showing how period and frequency relate. Here we see three sine waves, with the same amplitude and frequency, but different phases. They are shown at 0 degrees, 90 degrees, and 180 degrees of phase shift. This slide contrasts the time domain and frequency domain plots of a sine wave. The time domain shows the signal oscillating over time, while the frequency domain isolates the signal's frequency component. Finally, we see the time and frequency domain representations of three sine waves. In the frequency domain, the presence of frequencies 0, 8, and 16 Hz are clearly visible as distinct peaks. This slide displays the bandwidth of both periodic and non-periodic composite signals. The bandwidth is calculated as the difference between the highest and lowest frequencies, which in both cases is 4,000 Hz. A communication system consists of a transmitter, which processes the information source like text or video, and a receiver, which retrieves the information. The channel carries the signal, which is affected by noise. The basic elements include the transmitter, which converts a physical message into an electrical signal. The channel is the wired or wireless transmission path. The receiver converts the electrical signal back into the physical message. Attenuation is the loss of signal strength, reducing the power or amplitude. An amplifier is used to compensate for this loss and restore the signal strength before reaching the destination. Distortion is an impairment where the signal's shape or waveform changes, altering its form through changes in harmonics or timing, as the signal travels from the sender to the receiver. Noise is random, unwanted electrical interference that introduces random energy into the signal. This causes transmission impairment by adding unwanted components to the original signal. Next, we will focus on modulation, a crucial concept in communication systems. Here is a simple representation of a wireless channel in a communication system. Information goes from the source to the destination via a carrier wave over the wireless channel. Modulation offers several advantages, reducing antenna height, increasing communication range, enabling multiplexing for multiple signals, avoiding signal mixing, and improving signal quality, measured as SNR. Modulation is the process of varying one or more properties of a high-frequency carrier signal in accordance with a low-frequency message signal. The properties that can be varied are amplitude, frequency, and phase. There are three main types of analog modulation: amplitude modulation, frequency modulation, and phase modulation. Each varies a specific property of the carrier signal while keeping the others constant. This graphic visually represents the output signals for amplitude, frequency, and phase modulation, demonstrating how the message signal alters the high-frequency carrier wave in each method. Modulation schemes are broadly categorized into analog and digital. Analog modulation includes continuous and pulsed schemes, while digital modulation includes ASK, PSK, and FSK. An analog signal is a continuously varying electromagnetic wave, while a digital signal is a sequence of voltage pulses. A baseband signal is the information signal, and a passband signal is the modulated output. Modulation takes place at the transmitting end. Demodulation, conversely, is the process at the receiving end that restores the original baseband signal from the modulated signal. Let's explore the three basic modes of communication: simplex, half-duplex, and full duplex. These modes define the direction and timing of data flow between two devices. Thank you for watching this video. We hope you found this information on communication technologies insightful.